Welcome to my lesson on safety and classification of matter. The first thing I want to deal with is hazardous safety symbols that we would see in the home. And so lots of household products will have these symbols on them: poisonous, the explosive symbol, the flammable symbol, or the corrosive symbol. And each symbol might have something around it depending on its severity. If it has a triangle around it, that means it's just slightly a problem. If it has a diamond around it, that means it's more severe. And then if it has an octagon around it, that means it's really severe. So for example, this poison symbol with the octagon means it's really, really poisonous. This means that you just have to worry, it's just a caution. We've moved away from the household symbol system to a more comprehensive system called WHMIS, which stands for Workplace Hazardous Materials Information System. And WHMIS has 8 symbols and just a circle around all 8. And so the 8 symbols are the poisonous, which means you'll get sick and it's going to cause harm right away. Then some substances might have the almost looks like an exclamation point with a T, and that means toxic. And the difference between these two, poisonous and toxic, is the toxic symbol would be used for things that wouldn't be harmful to you immediately, but might cause long-term toxic effects in your body. And then the other symbols are corrosive, compressed gas, flammable, combustible, biohazardous, so any living organism, dead or alive, their fluids would have a biohazardous symbol on it. So for example, blood supply might have this on it, or anything containing saliva from another human might have this on it. Any organs. Then there's oxidizing material and dangerously reactive. I'm just going to skip these. We'll talk about these in class. Is just a little humor on some warning symbols I saw. Oop, went a little fast. Let's go back to the screen. So let's talk about my second thing that's important today in today's lesson, and that is taking matter, solids, liquids, and gases, and being able to classify them a different way. So all matter can be broken up into 2 categories. Matter is either pure substances, which means they can't be broken down into smaller bits and pieces, and their properties remain the same. Okay, so pure substances have properties like density, boiling points, melting points that never change, whereas mixtures contain 2 or more substances, and because of that, their properties might vary depending on how much of one substance or another. For example, you could have 3 different glasses of salt water, and they each could have a little bit more or less salt in them, which would make their properties, like their freezing point or their boiling point, differ. So the biggest difference, grade 8, between mixtures and pure substances is their physical properties. Next, our next item that I want to talk about is how we break down mixtures further. Mixtures can be broken down into mechanical mixtures or solutions. Mechanical mixtures mean we can see 2 or more parts, and solutions mean we know there's more than one thing there, but we can only see one part of it. Mechanical mixtures and solutions have other names for them. We can also call this homogeneous mixtures, homogeneous, Homogeneous, which I've got right here, homogeneous. Mechanical mixtures are also called heterogeneous mixtures, and there are some examples listed there for you. Now, things get even more complicated when it comes to mixtures because sometimes mechanical mixtures have smaller categories. Soil, for example, it's totally obvious that soil, you can see all sorts of different parts. So soil's a mechanical mixture. But something like muddy water, when you first make up muddy water and you shake it up, it looks kind of like a solution or all one thing, but it's not. And so we give a special name to mechanical mixtures called suspensions that appear upon first sight to be a solution, but if we wait long enough, the heavy particles will suspend out and float to the bottom. Then there's also another type of mechanical mixture which are called colloids. Now colloids have fine particles suspended in them, and you can kind of see them. You almost have to use a light shining on the substance to see them. So they're not really solutions, because if we shine a light in, we can see the other particles in there making it a mechanical mixture. For example, milk, if you shine a light on milk, you can see some of the fat particles. Or fog, if you shine a light through fog, fog's not really a solution. It's called a colloid. Let's deal with pure substances. Remember, the biggest thing about pure substances is they have definite properties that never change. Physical properties like boiling point. Their densities never change. And so there are two types of pure substances. Compounds, which are a mixture of elements, and then elements, which are from the periodic table. I think there's approximately 107 elements from the periodic table. Let's talk a bit more about solutions. Solutions are pretty neat things because we take a substance like this sodium chloride or salt, and when we put it into water, it seems to disappear on us. We can't see it anymore once it fully dissolves. And is it really disappearing? Well, in a way it is. Here's what's happening. This picture shows the dissolving process. Water comes in and it tears apart or dissociates the sodium and literally surrounds the sodium and the chlorine particles so you can't see them anymore. One last thing I want to cover. Let's see if you can classify some substances. Let's start with toast. Is toast a pure substance or a mixture? That's right. Toast is a mixture. Is it a mechanical mixture or a solution?